Hello folks, and I hope you are all doing excellent. So in the last video, we discussed about variables in Rust, and in this video, we will be discussing about data types. And if you're following the book, this is the second section of the third chapter, and here you can read about data types. And if you're following my blogs and Hashnote, this is a blog on data types in Rust. And I will link both of these in the description below. For now, let's go back to VS Code. So generally in Rust, there are two kinds of data. The first kind is what we call scalar data. This is more simple kind of data, like we have int, basically one whole number, and then we have float, that is our decimals, and then we have char, like one single character like ABCD, and then we have Boolean, basically our true false statements. And then we have little bit complex data, something that we call compound data. And here we have tuples, difficult to explain in words unless you know it already. And then we have arrays. And we have more complex data also, like vectors and strings. But for this video, we will be limiting ourselves to this much. We will also be discussing about them gradually. For now, let's try to understand what are ints first of all. So here, I can simply remove the println because I believe it's not required. And we can write something like this. Let x equals to 5 and then let y equals to 15. Now we can know for sure that both x and y are integers because they are storing 5 and 15, which are integers, basically whole numbers. But we can also declare that by writing something like this. So let x colon I32 equals to 5 and let y colon U32 equals to 15 or even U64 equals to 15. Now the question is, what is this I32 and U64? So I32 basically means that x is of the type I32 and I represents one signed integer. And U64 means basically another integer, but U in this case means unsigned integers. Now, unsigned integers are nothing but any integer that doesn't have a sign. And on the other hand, like signed integer means that any integer that has a sign. So I32 generally has a range from minus 2 to the power 31 to our positive 2 to the power 31 minus 1. And this is the whole memory of this I32. I mean, this is the range that it can store numbers because after all, every number is stored as ones and zeros in binary format. And this is the maximum it can store. And for the U64, the range is very simple actually. It is from 0 to 2 to the power 64 minus 1. And if you know a little bit how memories work, you will see that this is basically how much it can store logically. So that is how we represent integers, and these numbers can vary from basically I8 to I64. And then we have from basically, let's do one dot 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 here to represent that this is the range. And then we have from U8 to U64. And there is also one more type, and that is something we call I size and U size. These are a little bit smart, and what they mean is that they will track what is the operating system that we are in, and depending on that, it will take the I32 or U32 or whatever. And yeah, I believe actually after the I64, there is also I128 and U128. But generally, we have everything sorted between like this I32 or U32 and 64. Like, why do you need such big numbers anyway? I mean, you may need, but generally, that's all we need. And yeah, so that's all about integers. Like gradually with other videos, you will know more about it. Unless, I mean, it's very simple, so maybe you already know it. But that's all about integers. Now let's talk about floats. So floats are basically our decimals that we use every day. And here let me write let x equals to 5.5. And yes, we can write this because we have learned about shadowing in the last episode. So you can maybe revisit that once again. And so it is basically shadowing the old value of x, like the old value of x is no longer valid. And let me write let y equals to 15.6. And floats are more simple in a way that they are only of two types, F32 and F64. Depending on your operating system and architecture and stuff, it's best practice to use whatever your system supports. Like generally, most modern CPUs support F64, but you can use F32 anyway. Like everything depends on the memory, and that's all you need to know about storing decimals. And then we have our characters, and here we can write let x equals to a. So this is our character, and we can also do something more chill like this. So inside, I will give one emoji, let's say this smile emoji. So in Rust, and I believe in many modern languages, even emojis are characterized as characters. I doubt if this was the same case in our older editors or languages also. Maybe not, but it's good that we can now store emojis also. And lastly, we will discuss about true and false. So let x equals to true or let y equals to false. And lastly, let's also learn how we can print them. So printing is actually very simple. We have done in the last episode also. So we can do something like this. So x, and then there is also another way. So print, and inside curly braces, we will simply write y. And let me just copy these two lines and paste it above also, like after every variable. So here, as well as here, and also for the integers. So because why not print integers also? So here I will simply do cargo run. It will be building and we have 5, 15, whatever we have stored, we have it here. And actually it's kind of silly, but I forgot to mention or declare the data types for our characters and our booleans. So characters we can simply declare by writing char, x colon char equals to a, and y colon char equals to one smiley emoji. There is nothing else over here, no tips or tricks, that's all. And the same for booleans also, we will only write bool. Very simple stuff. So that's all about our scalar data types. So we have covered int, float, char, and boolean. And now we will move into our more complex data and we will start by discussing about tuples. So let's try to understand what are our tuples exactly. So tuples are how we store multiple data inside parentheses in comma separated format. So let me simply write one tuple rather than giving you a lecture. So we can write let tup, and here I will mention the data types. So let's say I want one I32, then one let's say U32, and then one character, and then one boolean equals to. In the same format, I will write let's say 5, 15, and then let's say F, and lastly, for a boolean, let me just give false. And so that you are convinced that we are storing I32, let me give it -5 over here. And this becomes one tuple. So why do we need it? It's hard to tell actually right now, but I can assure you that we need it for good reasons, maybe to make some games also. And how do we print it? That is one better question right now that I can explain also. So here we can write something like this. So we will do empty braces, and here we can write x point 0. And now if I simply print, I mean do a cargo run. So they're saying that we have some issues and we cannot like output x point 0, and that is because our tuple is not x, our tuple is tup. It's not x. I believe my blog also has some similar issues, but maybe you will understand after watching this video. And only for people who are reading my blogs, sorry to them, maybe you should watch this video. Or yeah, actually I can attach my video in my blog also. In Hashnode you have this cool, awesome feature. Okay, so as you can see, the top 0.0 is actually printing the -5, that is the first value of our tuple. And similarly, I can also print top 1, 2, and 3. There are also better ways to print tuples, but maybe that will not be in the scope of this video. But gradually, we will be using a lot more tuples and arrays and so many things, and you will know it eventually. So as you can see, we are getting -5, -15f, and false, so we can print our tuples. So for now, you can simply know that tuples are how we store data inside parentheses, and we can print it like this. And one more thing to note is these tuples cannot grow or shrink in size. Basically, they are immutable. That's all about tuples. Now, something we use more than tuples generally are arrays is something we will discuss right now. So, what are arrays? So, arrays are simply another way how we can store multiple data. So, let me simply write some arrays rather than giving a lecture once again. So, I will write let arr num, and here inside I will store let's say 1, comma 2, comma 4, comma 55, and I will create another array. Let me name it arr char, and here let me simply store a, b, and then let's say v. So what is the difference between arrays and tuples? So one difference is already something you can spot, and that is we are using one parenthesis in our tuples and one square brackets inside our arrays. Now you can say that that is all aesthetics, but there is also another difference, and that is in tuples we can actually store multiple data of multiple data types. But in arrays, we can actually store only of one type. So if I try to create some, let's say, air mix, and here let me simply write 1, comma, g, comma, false, and this will throw an error. So let me simply do a cargo run, and as you can see, it is throwing the error from this air mix. And if I simply remove it, we have no issues. It is throwing some warnings that you are not using the AirNum and the AirCare, but other than that, everything is fine. So that is one difference, and then we need to see that basically how we store, like not store, like how we get our individual elements. So we can simply do println, and here in place of dot, what we will do is AirCare, and then we will write 0. And for the AirNum also, we will write, let's say, 1. And we have to close with semicolon also because we are not writing JavaScript. It's Rust is very strict. We have already learned that. And here, as you can see, we are lastly getting some data. Yes or no? No, I think we are not getting. Let me do cargo run once again. And I think we are really not getting, and that is because both are cats. It should be random. I mean, we were getting the right things only. Our expectation was not right. Maybe only mine. So we have 2 and A. So this is correct. This is basically how we are getting, I mean, we should be getting our data. We generally use like square and then inside the index. The index is 0, 1, 2, 3. I mean, basics of programming, you already know that. And one more thing to note is we are not really declaring the type. So we can actually declare the type by writing something like this. So here I will write I32, let's say. And then we have to give how many elements will be inside our array. Like it is already deciphering the data types and what is the length, but we can also mention it over here. And similarly, this will be 1 char and then 3. If I write, let's say 4, there will be one issue. So for now, there is no issues. Actually, there is some issue. And what is the issue? The issue is here, which should be a semicolon and not a comma. And let me try to decipher if we are getting it or not. Yeah, we are actually getting it. That it should be one semicolon. I mean, this is some common error, so we will already be getting it like that. So now if I do a cargo run, there will be no errors and we having everything. Now, if I try to make it 4 or 5, we will be getting an one error. And as you can see, expected an array with a fixed size of 5 elements found with 3 elements. So basically, try to add few more things. So you're getting the kind of issues that we got and how we can fix it. So now if we run, and as expected, there will be no issues once again. So I believe that's all you need to know about data types for now. We have all discussed about the simple data types, like the more simple of the compound data. And gradually we will be learning about more advanced and more rusty concepts. So I believe that's it for this video. And if you have learned something new in this video, make sure to smash that subscribe button. It's absolutely free. And let's see you next time.